Now let's look at the present values. If we want to calculate the present value of multiple cash flows, we here just need to calculate the present value of every cash flow and then sum them up. Let's take a look at this example. If we deposit 100 today, 125 next year, 150 at the end of year 2, so this is the same timeline as what we looked at before to calculate the total future value. So now if we want to calculate the total present value of all these cash flows, we look at this timeline. The present value of the first one, we just use $100 divided by 1 plus I at the power of 0, because the first cash flow is at time 0, so it will be itself. Second cash flow 125 will be discounted by 7% at power of 1. Last cash flow it's 2 years later, so we discount it for 2 years. And once we do the discounting for every one, we sum them up. Total present value is 347, and that is the process of calculating the total present value of multiple cash flows. Here is another example. On this timeline, you receive $100 at the end of year 1, $300 at the end of year 2, and another $300 at the end of year 3, and then you pay $50 at the end of year 4. So all these cash flows are recorded on this timeline. Some of them are positive, and then some is negative. So to calculate the total present value of this whole thing, we try to calculate the present value of every one. You can try by yourself and see, for example, the first one, the $90.91 is actually $100 divided by 1 plus 10% at the power of 1. The present value of the second one, $300 divided by 1 plus 10% at the power of 2. You should get $247.93. This is to discount for 3 years, so 300 divided by 1 plus 10% at the power of 3. You should get $225.39. And the last one, it is negative. You use $50 divided by 1 plus 10% at the power of 4. You get a negative $34.15. So now you sum all of them up. You should get a total present value of $530. That is the total present value of all these cash flows together. We can also try to use the financial calculator to calculate the total present value without having to calculate every present value by ourselves. In my calculator demonstration video, I also talk about how to use your financial calculator to get the results for present value of multiple cash flow calculations. Try to follow that video, the examples in that video, and then come back here and try to practice with this question. If you have a BA2 Plus calculator, these are the numbers you should enter. Your CFO should be 0. Then the next couple of cash flows should be 100, 300, 300, and negative 50. When you enter these cash flows, make sure you have F01, F02, F03, F04, all being just 1, because you have one of each of these cash flows. And then once you press the NPV button, it will ask you for the interest rate. So enter 10 as 10% interest rate. Then press the NPV button, compute, and get the NPV. It should be 530.08. This is if you have a BA2 Plus calculator. Now, if you have a TI-83 kind of calculator, you should try this. Go find the NPV function and enter these numbers. 10 is actually the 10% interest rate. 0 is the 0 amount at time 0, which is consistent with the 0 CFO the other users are doing. And then 100, 300, another 300, and a negative 50. These are the cash flows every year. So make sure you enter exactly the same as what I have here. So all these numbers are separated by a comma, and then you have the braces here, and then you try to close the parentheses and press the enter button. You should get the NPV result. No matter what kind of calculator you are using, or maybe you don't want to use a calculator, you prefer calculating it this way manually, Either way, you should get 530.08, which is the present value of all these 4 cash flows. Now, what if we have an annuity when the amount of all those payments are all the same? So to capture the present value of ordinary annuity, the idea again is the same. We just try to calculate the total present value of every single cash flow in this annuity. So the first one be discounted for just 1 year, and second cash flow at the end of the second year will be discounted for 2 years. So depending on how many payments you have, you get the present value of every one. You sum them up. Now, if all these payments are the same, we have an annuity, which means all these cash flows, they occur pretty regularly. So you have 1 plus I at the power of 1, 1 plus I at the power of 2, and then maybe 1 plus I at the power of 5. So again, mathematically, it can be derived into something way simpler than this one because of the pattern behind this sequence. So now we are looking at the present value of annuity function or formula, and it is the payment amount multiplied by this annuity discount factor. And this annuity discount factor also depends on the interest rate and the number of payments. Now we can take advantage of this formula and try to calculate the present value of this 5-year annuity, each payment being 100, and the interest rate is 8%. So plug in the numbers into the formula, and you should be able to get $399.27. That is the present value of this annuity. We can also try to use the financial calculator. How to use a financial calculator to find PV? I do have that in my calculator demonstration video, so check that one out before you start working on this question. So now let's just input the numbers. 5 years, 8% per year, $100 each every year, and now we put 0 as FV. The FV being 0 here does not mean that the future value of this annuity is 0. If you remember from the last video, the future value of this same annuity is not 0 at all. It's about 586. But here we put it as 0 just to tell the calculator that in addition to all these 5 payments, there's nothing else. There's no additional payment at the end of the 5th year. So then we compute present value. Present value should be the same, $399, as what you got here based on the equation. So either way, no matter whether you are using the equation or try to use your financial calculator, you should get the same result. And I would recommend you to try both, to practice with both. We can apply the present value of annuity in some practical situations. For example, here, if you want to buy something that costs a lot of money and you try to pay by installments, so you will pay $6,000 per year for the next 4 years. So the question is, do you want to take this deal? If you can borrow money at 9% per year, then should you pay the manufacturer $20,000 per year now, or should you accept the 4-year annuity offer of $6,000? To think about that, you can try to calculate the present value of this $6,000 payment plan. If you are paying 4 payments, each payment being $6,000, using the 9% interest rates that you can get, the present value will be $19,438. So this is the present value of this 4-year annuity based on 9% interest rates. You can get this result either by using the financial calculator or by plugging numbers into this present value of annuity equation. Either way, you get the same result. So the cost of paying for this equipment over time is, according to your present value calculation, about $19,400, and that is less than paying to $20,000 cash. So it seems that while $6,000 per year may seem like $24,000 in total in 4 years, on the present value sense, according to the 9% interest rate, is still cheaper than $20,000 cash right now. So in that sense, you should take the annuity payment plan and pay by the installments. Here I have some practice questions for you. First one is, what is the future value of this 900 annuity payment over 5 years if the interest rate is 9% per year? Then for the same annuity, what is the present value? You can try both. You can try using the formula. You can try using the financial calculator. If you use your financial calculator to calculate the future value, this is the input. If you use your formula, this is how you try to plug in the numbers. Either way, the result for the future value should be about 5,386. Now, when you try to calculate the present value, you can input like this into your calculator, or you can plug in the numbers into this equation. Either way, the present value of this annuity is about $3,500. Now, what about annuity dues? Remember in the last video we mentioned that annuity due is an annuity well, the cash flow occur at the beginning of each period. So we showed a comparison between the ordinary annuity and annuity due here. For the ordinary annuity, each payment is made at the end of each year or each period, while for the annuity due, each payment is made at the beginning. So if you look at this 3-year annuity due, it is like moving this whole 3-year ordinary annuity 1 year ahead. So if you prefer to receive money earlier, then you would prefer annuity due, because under this annuity due, each time you get the payment 1 period early. So annuity due should be valued higher than the ordinary annuity. And how much higher? We say it's about 1 plus I times higher. Again, think of this whole thing as the ordinary annuity, this matching ordinary annuity being moved ahead for 1 period of time. So when we look at a future value of an annuity due, it should be the future value of this matching ordinary annuity, simply multiplying by 1 plus I. And if we are talking about present value, same thing. Present value of this annuity due should be the present value of this matching annuity multiplied by 1 plus I. So all the present value and future value formula and calculations we talk about so far are based on ordinary annuities. Then if you want to calculate the value for annuity dues, simply multiply by 1 plus I. Once you understand that, now in this question, what is the future value of a 5-year annuity due if each payment is 100 and interest rate is 8% per year? We did calculate the future value of this ordinary annuity of 5 payments, each payment being 100 at 8%. We calculated and it's 586 is 66. So then we just simply use that number multiplied by 1 plus I being the 8% interest rate, to get $633.93 as the future value of the matching annuity due. There is another way to calculate the future value and present value of an annuity due using your financial calculator. It requires to reset your calculator to the beginning, or say the BGN mode. And if your calculator is switched to the BGN mode, you can calculate the future value of this annuity due directly. To see how to switch to the BGN mode, if you have the BA2 Plus calculator, see the financial calculator demonstration video that I posted. If you are using the TI-83 kind of calculator, it's actually a little bit easier for you. Either way, I have the calculation demonstrated in the video. Check that video out. If your calculator now is at the beginning mode, you enter the numbers according to this annuity due feature. So 5 payment, each payment is 100, 8% per year, calculate future value. Now you have 633. And this is different from the 586 that you calculated under the end mode. Because under the end mode, you are calculating the future value of the ordinary annuity, and now under the beginning mode, you are actually getting the result of the future value for an annuity due. To calculate the present value of the annuity due, same idea. Recall that when we try to calculate the present value of the ordinary annuity for this 5-year $100 and 8%, we got $399 and 27. So to calculate the present value of the annuity due, we simply use this number multiplied by 1 plus I. So we got 433. That's the present value of this annuity due. You can also try to switch your calculator to the beginning mode and calculate the present value of this annuity due directly, and you should also get the 433 under the BGN mode. Alright, so before we move on to the next section, let's take a break and summarize what we have done so far. So far, we have learned to calculate the present value and future value of a series, or say a string of uneven cash flows. And then when the cash flow amounts are even, or say equal amount, that's when we have an annuity. So we try to calculate the present value and future value of an ordinary annuity. We also try to look at the annuity dues and try to calculate the future value and present value of the annuity due, either directly under the beginning mode of your calculator, or try to calculate the value of the ordinary annuity and then multiply by 1 plus I. Now let's work on a practice question about the annuities before we start a new topic. So if you are 20-year-old and you want to save $3 a day, which means over a whole year that will be 1,095, which is 365 multiplied by 3. So $1,095 saved and put into a brokerage account, which makes a return of 12%. Then how much money will she have when she's 65 years old? So if you think about this, this is a typical annuity question, actually typical future value of annuity question. Between now and then, there are 45 years, and every year a payment of $1,095 with an interest rate of 12%. So we can input the numbers into the calculator and calculate the future value of this annuity. It turns out to be just a little bit lower than $1.5 million. And that is by investing about a little bit over $1,000 a year. Well, if she does not start saving until she's 40 years old, and if she saved the same, how much money would she have at 65? So between 40 and 65, she would have 25 years instead of 45 years. Same 12% interest rate, same $1,095 per year. If you calculate future value, now the future value is substantially lower than the 1.5 million from the last slide. You get the idea that it is good to start when you are young, start saving and investing early as possible, because over time you can accumulate a significant amount of wealth because of the power of compounding interest rates over time. Now, the next question is, how much does she need to deposit or invest every year to match the same amount that she would have if she started at 20? Remember, if she started at 20, then by 65, she would have this $1,487,000. But if she only starts by 40, then she would only have 25 years to go. So then apparently she needs to save or invest much more than $1,095. So how much? That's when we try to calculate the payment, if we know the future value. If we input the future value and try to calculate the payment, here the payment is about $11,000, much more than or much harder than just putting aside $1,000 a year. So again, the lesson is it's good to start saving and investing as early as possible. Now, if you cannot start early, you can still catch up. But to catch up, you will have to save and invest much more to reach the same goal.